All right, let's jump right in. You hear the word correlated thrown around all the time, but what does it actually mean? And what's this other thing, covariance? Well, these are two super important statistical tools for making smart decisions, but they are also incredibly easy to get mixed up. So today, we're going to unpack them, see how they work, and figure out why getting them right is so critical to making sense of pretty much everything.
So here's our game plan. We'll start with the basics. What is covariance? Then we'll see how correlation kind of levels things up. We'll put it all to the test in a real-world finance example, and then, this is a big one, we'll tackle the correlation versus causation trap. And finally, we'll wrap it all up with why any of this really matters to you.
This is really the core question we're trying to answer today. I mean, when we see two things moving in sync, like, say, how much a company spends on ads and how much it sells, can we really say there's a connection, or is it all just a coincidence? Let's dig in.
Before we even touch a single formula, let's just use our eyes for a second. Take a look at this scatter plot. Every single dot represents a person, their weight on one axis, and how many kilometers they run each week on the other. What's the pattern you see here? It kind of looks like as the kilometers go up, the weight tends to go down, right? That visual gut feeling, that's exactly what we're trying to measure.
Okay, so to put a number on that trend we just saw, we need our first tool. Let's talk about covariance.
So here's the deal with covariance. It is all about direction. A positive covariance means that when one thing goes up, the other thing tends to go up with it. They're moving in the same direction. A negative covariance, like in our exercise example, means they move in opposite directions. It's a really simple but powerful first step.
But, and this is a huge but, here's the problem. If I told you the covariance between two stocks was, say, -250, what does that actually mean? You know they move in opposite directions, which is cool, but how strong is that relationship? Is -250 a little, a lot? You have no idea, because the number itself is tied to the units of the data. That makes it almost impossible to compare relationships, which leads us straight to our next tool.
And this brings us to correlation. You can think of it as the upgrade, the tool that solves covariance's biggest headache.
So what correlation does is it takes the one job of covariance, measuring direction, and it adds a second, absolutely crucial piece, strength. It does this by standardizing everything, which totally gets rid of that pesky units problem and gives us one clean number that tells us not just if two things are related, but how strongly. And this is the beauty of it. Correlation boils the entire relationship down to a simple, universal scale that goes from -1 to +1. That's it. A +1 means a perfect positive relationship. They move in perfect lockstep. A -1 means a perfect negative relationship. When one zigs, the other zags perfectly. And anything near zero means there's really no linear relationship to speak of. It's just simple, clean, and so much more powerful. You know, putting them side by side like this makes the difference crystal clear. Just look at the range. Covariance is all over the place, from -infinity to +infinity. But correlation, it's neatly tucked between -1 and +1. And the units? Covariance has these weird combined units, but correlation is unitless. This table really says it all. It's why most of the time we use correlation to really understand what's going on. Okay, that's enough theory. Let's see how this stuff actually works in the real world. Maybe in a place where the stakes are high, like finance. We're going to see how you can use these tools to build a smarter, less risky investment portfolio.
So here's a quick look at the process. An analyst would first gather up all the data. Then they'd do a few calculations to get to something called the covariance matrix. And from there, it's all about reading that matrix to figure out the risk.
Step 1 is pretty straightforward. You got to have some data. So for our little example, we'll just imagine we have a few potential future prices for two made-up stocks, stock A and stock B. This is our starting point. So we run through the calculations, and boom, we get this, the covariance matrix. Now, I know this might look a little intimidating, but it's actually pretty easy to read. The numbers on the diagonal are just the variances of each stock with itself. The number we really care about is the other one. And that number is -250. So what does that little number tell an investor? Well, that minus sign is everything. Because it's negative, it tells us that these two stocks tend to move in opposite directions. So when stock A has a good day, stock B tends to have a bad day, and vice versa. And for an investor, that is the holy grail of diversification. It means you can pair these two together to lower your overall risk, because the losses from one are likely to be balanced out by gains in the other.
Okay, we've arrived at what is, without a doubt, the most important part of this whole discussion. We've seen how powerful it is to find these relationships in our data, but there is a massive critical trap that we all have to avoid. This is like the golden rule of data analysis.
This quote says it all. Just because two things move together does not mean, I repeat, does not mean that one is causing the other. This is probably the single biggest and most dangerous mistake people make when they look at data.
So let's be super clear on the difference here. Correlation is just an observation. It's saying, hey, look, A and B seem to be moving together. That's it. Causation is a much, much bigger claim. That's saying A is literally making B change. Finding a correlation can be easy. Proving causation, that's incredibly hard.
So how does this happen? Usually in one of two ways. First, you have what are called spurious correlations, where two things look related just by pure random chance. But the more common culprit is a confounding variable. You've probably heard this one. Ice cream sales and drownings are highly correlated. Does eating ice cream make you drown? Of course not. There's a third thing, hot weather, that's causing both to go up. That's a confounding variable. And trust me, they are everywhere.
So let's bring it all home. Why did we just spend all this time digging into covariance and correlation? Well, because understanding these ideas is what separates just looking at data from actually getting real, valuable insights out of it.
And this stuff isn't just academic theory. In finance, it's used every single day to manage risk. In business, it helps you figure out if your marketing campaigns are actually working. In machine learning, it's key to building better predictive models. In the social sciences, it helps us understand if a new policy is actually making a difference. This is fundamental to how we make better decisions with data.
So, I'll leave you with this question. As you go about your week, start noticing the patterns and relationships around you. And when you see one, ask yourself, is that just a correlation, or could there be real causation at play? And always, always ask the most important question of all. What am I not seeing? What hidden factor could be secretly driving the whole thing? Thanks for watching.